We are back to Precalculus. We are still with parabola and sketching the graphs of parabola and laying down the characteristics of a parabola. But we shall begin with the equation of a parabola with vertex at the origin. Now, before we go on with introducing you to the equations of our parabola, I wish to call your attention to these two words, horizontal and vertical. And the reason for that is, when I was a student, just about your age, I have difficulty seeing in my mind what is vertical and what is horizontal. So when someone says the line is horizontal, what I would do is I would look at the ceiling, I will close my eyes, and I will think through it again. What is a horizontal line? I cannot quite remember or recall easily the picture of a horizontal line. I was able to fix that by always recalling this scene. So this is the sky and this is your ocean. So where the sky and the ocean meet is what you call the horizon. And so that is where the word horizontal came from. When you're out there in the mountains, you're looking at this scene right in front of you, the region in space where the sky and the land meets is what you call the horizon. And the horizon is a horizontal line. Whenever we talk about horizontal line or the axis is horizontal, then you know right away that that is how the axis should look like. Another word where I had difficulty seeing in my mind its position is the word vertical. I was confused about horizontal and vertical. So what I did was I looked at my experiences. And when we were kids, we used to play this, or we used to challenge each other. And we said, mag-vertical ka nga, mag-vertical ka nga. Oh, what it means is you are challenging the other person to tumble. Can you do this? Can you tumble? Or kaya mo bang magtumbling? We used to call that mag-vertical ka. So a vertical is somewhat like this. When your axis is horizontal, it ought to appear like that. When your axis is horizontal, your parabola can either open to right or to the left. When your axis is vertical, the axis is standing up, and your parabola can either open up or open down. Parabola whose vertex is at the origin. So that is the origin. This is your parabola. That is your origin, and this is your parabola. So we shall be talking about two sets of parabola here. One is in which the axis is vertical, and then the other one is where the axis is horizontal. The equation of a parabola with vertex at the origin and focus at A0 is y squared is equal to 4 times a times x. If a is greater than 0, the parabola opens to the right. Okay, so somewhere here is your focus. When it is less than 0, your parabola opens to the left. So when your vertex is at the origin and your focus is A0, it's either to the left or to the right of your vertex, then your axis is horizontal, and this is the form of your equation. What gets squared is y. Parabola with vertex at the origin. If your vertex is at the origin, look at that, and your focus has coordinates 0a, so this is the y coordinate, so either the focus is located above or below your vertex. So in which case, if your focus is either above or below the vertex, that means your axis is vertical. Your axis is vertical. If a is greater than 0, your focus is above the vertex, your parabola opens up. If a is less than 0, that means your focus is below the vertex. That means your parabola opens down. The equation of a parabola with vertex at the origin and focus at A0, again, if your focus is to the either left or right of your vertex, your axis is horizontal, what gets squared is y. When your focus is either above or below the vertex, your axis is vertical. If A is greater than 0, your focus is above the vertex, so your parabola opens up. If it is less than 0, your focus is located below the vertex. Your parabola opens down. More on the value of A. So A is telling you the directed distance of your focus from the vertex. This is not just distance. Because when you say distance, let's say for example 5 meters. Somebody is 5 meters from you. So that somebody can be standing in front of you, at your back, or maybe that person is to your left or right. That is what it means when you say someone is 5 meters from you. So that is distance. But when the distance that we are concerned is directed distance, we can tell where is that object in relation to you. So if our axis is vertical, if A is positive, then the focus is located above the vertex, in which case our parabola opens up. If A is less than 0, then the focus is located below the vertex and our parabola opens downward. Similarly, if our axis is horizontal and A is greater than 0, our focus is located to the right of our vertex and our parabola opens to the right. If A is less than 0, our axis is horizontal. If A is negative, the focus is located to the left of our vertex, in which case our parabola opens to the left. Another new term or new idea about parabola which was never spoken about in quadratic functions, the latus rectum. So the latus rectum is giving to you or is giving you some measurement about the width of your parabola, because a parabola can be narrow, it can be wider, or it can still be a lot wider. And the measure of that width is what you call the latus rectum, or the length of the latus rectum. It is the length of the line segment that is measured right there from the focus. It's equal to the absolute value of 4 times A. So how do you locate the latus rectum and how do you measure it? Again, this is your vertex, this is your focus. You draw a line perpendicular to the axis. It will intersect the graph. It will intersect your parabola. It's right through the focus. Their endpoints are located in the parabola. The length of this will give you the focal width. So if we shall investigate this parabola, what is the width or what is the focal length or focal width of this parabola? Well, you count how long is that line segment. Okay, so 1, 2, 3, 4. Or you can use this. It's equal to the absolute value of 4 times A. What is A? A is the directed distance of your focus from the vertex. It's -1 here. This length is the absolute value of 4 times -1, so it's going to be 4. How about this one? Let's say, for example, we are given this graph. The focus, the vertex, the latus rectum. What is the focal width? 1, 2, 3, 4, 5, 6, 7, 8. That's the length of our latus rectum. Or we can compute this. It's the absolute value of 4 times A. A is the directed distance from your vertex. 1, 2. So 4 times 2, or the absolute value of 4 times 2 is 8. So that is the focal width of your parabola.